That's why it would probably be better for you. Okay, it's going now. Thanks.
Yes. So everyone, welcome to workshop 4 of the Intro to Robotics workshop series. Today we'll be covering Intro to Programming with the focus on the Raspberry Pi and Python. We'll get into exactly what the Raspberry Pi is and why it was a focus of this workshop, at least up until classes ended up online. So first off, this workshop does not really have any prerequisites. No prior programming experience or really other content is expected. And we'll end up covering in this workshop all of the content for the next 2 workshops as well. So this is kind of the full package getting us throughout the series. As for our content today, we're going to be covering the Raspberry Pi. What is it? Why is it useful? Covering the Unix shell, which is a command line interface, as well as using GitHub in that command line interface. Covering programming basics in Python. These are kind of some core conceptual tools that are useful throughout programming, including variables and data types. And then we'll cover sort of advanced topics that are maybe a bit more complex, but also, again, very useful. So functions, classes, and certain things in Python like lists we'll get into. So let's first look at the Raspberry Pi. To start out, Raspberry Pi is just a series of computers. They're created by the Raspberry Pi Foundation. I'm trying to fix the Windows not covering buttons. Sure. Which is a UK-based charity. The goal of this charity is to put power of computing and digital making into the hands of people all over the world. So they're really trying to democratize and give access to technology. And this is useful for robotics because these are fairly cheap, small, like credit card sized computers. They have a very accessible operating system, so they're kind of easy to use. And they also have great power because of their input and output ports, which kind of connect into servos or circuits directly. One example is just the Raspberry Pi 3B Plus, which is like a more recent model that came out maybe 2016-ish, I'm not positive. But for $60, you can get its case, memory card, and a power supply, as well as the computer. You'll end up with just a computer that can run an operating system. You could play very slow Minecraft on it with 1 GB of RAM, HDMI video output, USB ports for keyboard and mouse, as well as a camera and GPIO pins. So these GPIO pins are kind of the difference between this type of computer and maybe like a standard Mac or Windows, where GPIO pins stand for general purpose input and outputs. And so you can easily connect like breadboard wires or other circuits into the Raspberry Pi to read signals or to send signals throughout the robot system, in helpful and hopefully intelligent ways. This is just an example of what that looks like. So Raspberry Pi is, I don't know how large your screen is, but assuming the Raspberry Pi is about 4 to 5 inches tall on your screen, this is maybe close to life size, where we have the USB ports, we have I think HDMI is this, but Ethernet, GPIO pins, there'll be camera and display ports, but you end up with a complete computer that could easily fit on a robot, which is nice. As for what an operating system is, you've probably worked with one in the past if you've used Mac or Windows. The operating system that comes with Raspberry Pi is Raspberry Pi OS. It's based on Debian, which is a distribution of Linux. Really, Linux is just an open source operating system that's pretty popular in academia and robotics because it's secure, pretty quick, and you can kind of access the powerful tools within the command line and within the operating system more easily than Mac or Windows, which kind of protect users from having to deal with the nitty-gritty. And Linux is also widely used for robotics. It's the basis where the ROS ecosystem tends to operate, and ROS is sort of an open source tool for robotics software development that's used in I would say most modern robotics research of sufficient complexity. So really the bottom line is Linux is useful in both this low-level Raspberry Pi work that we're kind of starting an introductory project with, as well as all the way up to high-level advanced robotics projects potentially in the future. So first section kind of done. Does anyone have any questions about those topics, I guess? I'll drink when I can. So next up, let's actually get into something we can directly use, the Linux or Unix shell rather. So the Unix shell is an instantiation of a command line interface on Unix-based systems. So it's on Linux and it's on OS X. And command line interfaces are sort of an alternative to graphical user interfaces, or GUIs, which you're probably more familiar with. So we're going to end up using this command line interface to navigate the file system, to create folders and files, and to run programs just by typing commands. And we'll cover some of these commands. You may have seen them, of course, in the setup as well, but we'll cover, what was exactly going on. First off, let's look at like what is the standard maybe concept you're used to. This is kind of a GUI setup where if we're navigating my computer, for example, and we want to look for some file or folder, we can see, maybe we went into your robotics folder and then workshops and your robotics workshops, etc. You can kind of see that folders form a hierarchy. When we're sort of inside a folder, we're both maybe containing folders below us, but we're also inside of folders that came before or above. And at least on Mac, there's a root directory kind of called, it's my name here, Bennett, but this home directory, you'd have, the desktop and documents within it. And we'll look at that hierarchy from a different viewpoint through the command line as well. So to open the shell, it's just called terminal on Mac, LX terminal on Raspberry Pi, and PowerShell on Windows. Windows also has an Ubuntu command line you could probably find in like the Windows application store or something. And this will just give you the same syntax, but most of it does overlap. I think in the tutorial, I specifically say, or in the setup steps, I say like everything's the same except for the ls command. So when we get to that, I'll try to note it. But you should be able to test these things like on your machine as we're going through this. So first off, whenever we're in the command line, we're kind of in some location. And we're typically, I'd think of it as like we're in some folder called the working directory within the file hierarchy. So to find out where this is, two commands are pretty useful. There's pwd, and this will print the path to the working directory, which is kind of like what is above us and how did we get here. And then you can ls, which lists everything that's in the current directory to kind of find out what's directly below us. So between these two examples, we can see this workshops folder that we're currently in is inside this list of folders. And then when we type ls in my root directory here, this little tilde symbol, we end up seeing, this is what is inside that root directory, documents, downloads, kind of standard stuff. So to, actually do a command or make a command occur in the command line, just type it and press return. It's the one other note there. We can kind of see between the command line interface and graphical interface here that the same hierarchy can be displayed in, two different ways pretty easily. Inside of desktop, which was inside of Bennett, we have your robotics and then workshops. And then in the graphical interface, I've gone down one more folder as well. But, the same information can be shown either way. And similarly, inside of the root directory Bennett, we have all of these items, which we can see in the example. We can also, of course, move around once we know where we're at. So CD stands for change directory. If you just enter CD and nothing else, it will move you to the top of the file stack, or top of the tree, I guess, to the root directory. You can think of this, as I say, at the top of the file tree. CD space dot dot will move up one directory, like into whatever contained where we were at. So of course, if you run it enough, you'll probably end up at the root directory because that's the top. And then CD directory name will move us one down. So if we're in some directory and we had some folder called like workshops below us, we could type CD workshops to move down into that folder. And of course, all these are just examples, but we will see some actual practice as well. I think the final like file tool we want to know is how do we make new folders? And this is done using the make directory command. So this is the syntax. Whatever you put here will be the name of the new folder. And you could then type CD, the name of that folder, to move down into that. So kind of as an understanding test, I guess, would anyone want to try to describe what sequence of steps we're doing here in these like 5 commands that occur?
I know for the second step, so you're making a new folder called new folder. Then you are listing what's inside of that folder. Or sorry, what's in your current directory, what's there, and you have something called new folder. And then you're moving to new folder, right?
Yeah. The one note for the top line is like, we typed ls and nothing happened. And that's just because nothing was there to, list. We were in an empty directory already, but yeah, that's entirely it. And then we can see in the end, what is the path of where we ended up? We're in this new folder we created inside of folder. So yeah. And this workshop will actually have like a number of examples. So don't worry that we're getting behind on time or anything. Next up, let's get some files into these folders. Git is a version control system. which kind of just helps programmers work together and synchronize their code, across a large team. GitHub is one website that sort of hosts this service, and GitHub is free, which is pretty great for a lot of CS majors. The setup involved downloading workshop code from my GitHub using the command line. I think we have like 1 or 2 people more here. Are we all generally in a setup process where we either have downloaded this code or we're at the step where this would be the next thing? Like whatever said, do the slides. Here's the slides. If you haven't yet, cloned this software, we can go through the steps kind of shortly right now. So we're trying to get this UR Robotics Fall 2020 repository. And this is the command to do it. Git clone, and then whatever the link is to the repository, we'll copy whatever folder online we're looking at, and it will bring it into the current working directory. So you can do git clone, and then this link, and that will sort of copy all the workshop's code wherever you're located in your file tree. So if you want to go somewhere like your documents folder, you could. We have the ability to do examples here. For example's sake, I'm inside of a workshops folder here. I've actually already, I can't see because the stuff covers it up. Well, we have that, yeah. So inside of this folder is the current workshop directory. So this is somewhere where I would want to have cloned it. But if I wanted to clone it again here, the point is you can navigate around so it's somewhere appropriate on your system. To do so, this is just the link or the page where you can find the link for the repository. So first off, to find my GitHub, you can look up like GitHub Bened H will probably bring it up. That's a hyphen, and that'll bring you to like this page, which is just all of the code I have online. If you go into repositories, pretty close to the top should be the current workshop folder, and then you can find the link to it right here. So you could copy paste this and git clone this. And I can't do it because I already have it installed, but that's what you would do to get it onto your machine. So hopefully everyone's able to follow along with that. There's the link, there it is. And so at this point, between the setup steps and what we've just covered, you know enough to actually like look through this folder using the command line. So you could go into that directory, look around, and I would suggest small exercise, try to navigate into the intro to programming directory. If you want to use the GUI, that's totally fine, whatever's easiest, but practicing moving around the command line tends up being useful because you're often like trying to run files in different places. So it's not a useless skill to develop. But if you're able to get into intro to programming directory, that'll be the next step. And I'll give a minute for that, as well as any questions if there are any right now.
Yeah, can you go over the how you got the link for the files and everything?
Yeah, were you able to find the GitHub at all?
Yeah, the link that you posted for last workshop, I click on it. Yeah, it's the same page, except I don't have this green button you have over here with code. I don't get that one.
You might be inside of like the subfolder here, intro to programming, and on GitHub overall, we want to be at the top level of like the repository itself. I should probably define that term, where the repository is just the folder in which all of the things GitHub's going to look at. GitHub's going to care about the overall folder called the repository, and then inside of that folder are other folders. So really there's no difference except for the repository is the one we selected as, this is the root of whatever the small subtree we're going to upload to GitHub is. But yeah, main repository will have it, and the command is git space clone space that link. And I think, yeah, all machines should have GitHub by the time we're here in the setup process. Yeah. I'll probably keep going, but if anyone has questions, or actually like, is anyone still working on stuff, or we're good to go on? It's probably good to ask. All right, let's get into some actual programming then. Sure. So we're going to be covering variables, duck typing, and primitive data types in this section. I think variables are like the most important thing we're going to cover today. All aspects of programming are built using variables. And so variables kind of contain three pieces of information that are really important. We need to ask, like, what is the variable called? How are we going to refer to it? What kind of, or what data does the variable refer to? Just in the general sense, like it could be 1, 2, 5, it could be the object of a car. And the third question maybe to ask is, what kind of object is that value that we're pointing to? And then we'll, of course, look through these three things individually. First off, variable names are just going to be some word in Python. So start with the letter underscore, contain only alphanumeric characters or underscores. So once you have a space, it's 2 different tokens to Python. And then don't use any of these words as a variable name, or bad things happen because Python doesn't know if you're trying to define a variable or start some fancy command like an if statement. So don't name variables if. And then finally, just there are 2 kind of cases that tend to come up where you can name variables. Like if I wanted to name a variable like the best of my options or best node, I can't do best space node, obviously. And so you may want to do best underscore node and all lowercase, or you could do best node capital letters and snake case and camel case, are just kind of 2 common ways to format names. So maybe get to know the names of those styling types. Next up, we had the variable and it has some name. What value is it actually pointing to? So variables are always pointing to or set to some value. You could think of this like the object that the variable refers to, or maybe even more simply, like the variable is a bucket and it's going to contain some type of item. Okay. The variable is created as soon as it's assigned some value, and then you can change this value in 2 ways. In Python, at least, you can just directly assign new values to a variable. So we could say, let's go to the command line, open up Python, and let's say I set variable a to like 5. This is how you write that. Okay, so now a is 5. If I say to print a, what do you know? It prints 5. But the thing with Python is I could then set a to like anything else. Like I set it to some string here, just complete gibberish, and Python doesn't care. So we'll get in a bit to why that's weird, but for now we can directly change variables kind of however we want in Python. There's piece 1. And piece 2 is we can also change things indirectly. Like you could pass maybe an object into some function and it'll do some operations on that object. And you never actually reassigned the variable, but maybe the thing that the variable is pointing to got changed in some way. And it's just good to be aware that that can happen because objects end up being complex. Kind of on that topic, then the values that the variables can take are either primitive or complex data types. So primitive data types are simpler, like integers or strings, and complex are kind of anything else. It's somewhat of a vague distinction. Complex data types are typically either built into the programming language, defined by imported libraries, or you can define them yourself. And we'll get into what that looks like about 10 minutes from now. I've added this slide sort of as an example from a few different languages so we can see, in practice, like out of the, let's say Java examples here, what is probably the value, the data, and the name of each of these variables? Anyone want to take a stab? I mean,
can you ask that again, Brennan?
So yeah, we're looking over, like I'm trying to describe variables as being described by a name, variable, or a name, a value, and a type. First off, what is the name of each of these variables? Probably. I kind of just, yeah. And then do you think that the type is probably Boolean or false?
Boolean.
And that leaves us with 1 answer left. So yeah, in Java, that's the syntax. Hooray, I think we get it. I'm not trying to make this painful, but if you answer, we can move on. Yeah. Similarly, in C++, same thing happens. We have the type, we have some name, and we can assign it a value. And actually up here, maybe as a note, you can assign values from functions. Like if a function returns something back, you could assign that to a variable. And that's maybe good to get familiar with now. And then we kind of see something weird is happening here with Python where, like, what's up with that, huh? There's no type. And this is worth noticing in Python early on. Python is duck type, and the way that this is typically described is if it walks like a duck and it quacks like a duck, then it must be a duck. What this really means is Python was lazy and doesn't make you define types like explicitly, but variables are still going to have types just by the nature of how variables need to work. So you can pass anything as any argument into a function typically, and you're never like, there are no language-based checks on type. And so typically the only warning ends up being your code crashing if you're giving like the wrong data types to a function. So it's just good to be aware of this because it's both powerful, but also sometimes dangerous. So that's why Python's kind of weird. Some primitive data types are just good to know. We have integers, which are whole numbers. I kind of showed an example already where this is how you could define an integer. There are floats, which are really any kind of other number, typically with decimals. So you could think of that as like whole numbers and like rational numbers or real numbers maybe. And maybe a good question to think through is when would you want to use one type over the other? Like why would you use integers over floats, for example? I know my answers to my questions, but yeah, like integers being whole numbers, maybe you're counting something. And a second idea is indexing into arrays. No, the chat does not have anything. Third primitive data type are strings. You can define strings, putting text between two quotes or two apostrophes. Either one works. So any questions for that section? Give it like.
Yeah, I had like a small question.
Yeah.
So you said that we don't have to explicitly define what data type, like, is it going to be an integer or a float?
Yeah.
So can we control if when a variable like suddenly changes from being an integer to a float, or?
I mean, that's a good example. So first off, let's just clear this. By the way, the command clear in the command line clears the screen, which is kind of nice. And then I'm opening up Python 3 by just typing Python 3, and it begins like an interpreter. So I think this is probably best served by an example. We could say A is 5 and B is 5 and then a decimal point. Which one of these is probably going to be the float of the two? I mean, it's going to answer, so don't rush. But yeah, like because we put a decimal point inside of B's definition, Python's going to make it be a float. This isn't too important because like numbers, as long as you're doing like sensible operations with numbers, adding, multiplying, probably dividing if it's not 0, all these things are going to work whether things are integers or floats. But there are certain weird cases where there's a thing called integer division where let's say we had 6 divided by 2, or no, 6 divided by like 4. It's going to be 1.5. That makes sense. But a weird thing happens if you have, I don't know if this will work. Let's see. Yeah. So there's a thing called integer division. Basically, it just rounds to the nearest integer. So we had 6, we divide by 4. It should be 1.5, but it rounds down because integer division. The point is just use floats if you're trying to do math with them typically because integers can be messy. If that doesn't make a ton of sense, it's not that important, but just generally use floats if you're doing math because, non-whole numbers are probably more common to be a result. Sure. Anything else for that section?
I have a question about variables.
Yeah.
So like I know for like lists, like if you don't want them to be like mutable, then you can just use like tuples. But like for variables, if you don't want them to be reassigned, like is there like anything for that, or are they just like mutable?
I'm not sure. So in other languages, no. Okay, well, I'm guessing syntax. In for example, C++, you can write const before a variable. So you can say like const a is 1 or const int a is 1, and that would never change. But in Python, I'm not positive. Frankly, Python's a very accessible language, and I'm using it here because it's useful for syntax and it's useful for the Raspberry Pi and controlling stepper motors and whatnot. But C++ or Java are typically better for like doing controlled things like that, or even C. So the answer is yeah, it's const in C++ or C, but here I'm not sure. It may exist. And that kind of raises one other idea, which is, programming languages, I'm not going to teach it in one day. I'm just trying to introduce some ideas and syntax here, but there are tons of documentation and tutorials online for all sorts of things. So we'll get into some topics here, but
Bennett,
there's a lot of examples out there. Yeah.
Real quick. So really quick point, and so same thing. I brought this up before, but if anyone here is going to do ME, this is their major or anything like that. I brought this up before, but you'll take a class called ME160, which covers MATLAB, and going through your slides you're talking about, it's very similar to Python. So there are things to be learned there if you're going for mechanical engineering as well. So yeah, just another cool little thing.
That's good. Yeah, I mean, these are very central ideas, so hopefully I'm giving them justice. Let's look into some more stuff. Though. Functions are kind of repeatable pieces of code. You could pass something into them. Maybe you don't need to, and the function is going to do something with them. It's a pretty simple example. Let's take the print function. This is built into Python, so you can call it kind of wherever you want. It'll always be there. And you can call the function by passing in any string as an argument or an input to the function, and that will print out the string to the command line. So this would be an example hello world program, print out this string, which we define as hello world. And that's all there is to it. It's going to do something with the input it's given. Great. That one's pretty simple, I think. But we can also have functions which return or actually give us information back. That's called an output or return value. And this is useful because functions maybe take something in, they do some processing, and then they return back out whatever the result was. So you could maybe write a series of steps and break them down into functions so each little part is more manageable. For example, let's take the input function. So when you call this function that you pass in some string, it's going to do three things. It's first going to print out whatever it was given. It's then going to wait for the user to type something and press return. And then it's going to return back to the overall program whatever the text was that was typed in. And again, I think simple example probably serves this best. First off, what is A right now? A is 5. Okay, well, let's say A is equal to the output of input, I don't know, please input your name. So it's going to print out, please input your name. I'm going to type something in. I should have, done some better string formatting, but I didn't. So I put Bennett, and now A is equal to Bennett. If you were, nicer to people, you could maybe put a colon and a space, or you could do a slash or \n to make a new line inside the string. And so then when I press this, we have a new line after this colon here. I can still input my name, and A will still be, set to whatever input returns back. So there's a function. Next up, we can define functions using the def keyword. You can give whatever name or arguments you want, and then whatever you give, you're kind of naming different variables that will be available within the body of the function inside this definition. So as an example, let's look at a function where we want to add A and B. It's going to take some input A, some input B, and try to return the sum of those two. If anyone wants to type in chat, what would you put in this line to make this function work? I don't know how complex that seems, but I think it's feasible. If anyone has any questions, also figuring out why this isn't clear is probably useful too.
Would you do a line of code that says C is equal to A plus B before return C?
Yes.
Okay.
I mean, yeah,
Nice.
that's the idea. And at that point, C exists within this little scope that we're working in, and we can return C because what do you know? It now exists. Simpler version, maybe you just do return A plus B, but we're trying to get concepts here, not perfect code. We also mentioned complex data types, and this kind of comes up as we're working with functions and then classes, where complex data types were anything that wasn't one of those simple types we already mentioned. And there are other simple types, but the idea stands. There are three main places complex data types will come from. You can use ones that are built into the programming language, like lists. You could define them yourself, maybe writing a class for a planner or a step promoter. And then you can also import others' code so that you don't have to redo things that have already been done somewhere else. And I'll end up looking a bit into defining a simple class just for exercise sake today. So a class is kind of a standard blueprint, and you can then make a bunch of different instantiations of the blueprint. Each of these objects is going to have the same variables and same methods, but each individual object can have different copies of those values. For example, we've got a car class. Let's say it has a make, a model, some top speed, and a number of seats. We could have two different objects instantiated of this class, and they're going to contain different items or different values for their member variables here. But they are the same object in some way, and maybe we have some operations that are like car.drive or car.park. You could call the same functionalities in a useful way. Once the class is defined, you can create multiple objects of it, as I mentioned. But to instantiate each one of these objects, you're going to need to call the class constructor. And this is just a function that will create a new instance of the class and return that new object. And that will have the same name as the class. So we'll look at the exact syntax here. First, just focus on this line where we're setting variable motor1 equal to the constructor of some stepper motor class. So then it's going to be equal to this value. There's this idea of member variables where you have different variables that are named within the context of the class. Python can access these directly to change them or just read them. And we can read the angle of the motor and print it here, or we could set it just by setting motor.angle. So that's the syntax for member variables in Python. You can also have member functions, which are just object.function name, and you'd pass in whatever you'd normally need. And that's kind of a lot. Based on the time, yeah, I think we have time for it. I'm going to try to I'll just give somewhat of an idea of the syntax here. It's not insanely important, but seeing the syntax is maybe somewhat useful compared to the ideas. So this is how you define a constructor in Python. I'll explain what these things are. So let's say we want to define a class rectangle. I propose that we care about its length, or let's say its height and its width maybe. So let's make some arguments so you could pass in whatever definition you want to give to its height, some definition to give it its weight. I can make this bigger actually. That's my bad. Maybe that's a bit better. New line. And so we want to store these variables in the class somehow. So to access the variables in a class, at least when you're in the class, you do self dot whatever the thing was. So let's define a variable called self.height, and we're just going to set it to whatever the argument was passed in for the height. Similarly, let's say the width is passed in like so, with arg, sure. And okay, that'll store these things that were passed in, and now we have them as height and width in the class. Great, that function's done. And what's maybe a useful thing to do with a rectangle, I think as I was doing this earlier, I tried, let's do a perimeter. So let's say I want to get the perimeter of the rectangle, and it's going to be a function, and it doesn't need any arguments. Actually, it just needs to access the variables of the class. So you put self again because it needs to access what the class owns. So this one, I think, is pretty simple. To do the perimeter, you need 2 times the width plus 2 times the height, if I'm remembering correctly. So something like this should work, where we have, actually we should do 2.0 because safety. Just better practice, I guess. 0 self dot height, and that will implicitly add parentheses on either side of this. So you can add parentheses, often throughout code, just to kind of say this is a concrete thing we want to make sure finishes before anything else outside of it accesses it. So it'll compute that number and then it will return it. Great. Press return twice, that should finish the class. Let's see if that worked. Let's say R is a rectangle. It's going to have height 3, width 4, I don't know. And what is its perimeter? It's 14. I think that checks out. The example is simplistic. I don't think it's terribly educational, but just getting the syntax of underscore underscore init is how you define the constructor of a class. It's kind of arbitrary, but that's how Python does it. And then classes also want to pass in self, just because to access to access the stuff I care about in this class, you want to have a reference to the class. Again, Python did it this way. The other language maybe do different, but there's an example, just to at least have that. Any questions on that class thing before we go into lists? It's not terribly important. So we're also going to introduce just one built-in data structure in Python, lists, and you can create these in a few different ways. Anytime you see 2 rectangular brackets, that's going to kind of define a list in Python. So you can create an empty list. You can create a list that is not empty. And you can also create lists using this range function. Now, when you call range n, where n is some integer, the function is going to create and return a list containing all integers from 0 to n-1. And I say here that list 3 equal to range 3 is going to be identical to list 2. And I think it's useful to try to think through why. It maybe is also simple, but calling range 3, so it's going to have the elements 0, it's going to have 1, it's going to have 2, and it's not going to have 3 because range cuts out that last one. So we're going to put the same list because, they're both going to have the same elements. Now to access items in a list, you need to like index into it. It's not very useful to store a bunch of stuff if you can't get it back out. So you can index into a list using 2 brackets surrounding some number, like following the name of the list. And then list indices start at 0. So like A1 is going to be the element in the list corresponding to index 1. And because the indices start at 0, can anyone guess what B and C are going to be equal to here?
B will be 5 and C will be 6.
Yeah, does everyone understand like why? I think that's the important part, of course. Yeah. I mean, yeah, indexing lists, as long as you remember it starts at 0, it ends up, being pretty straightforward. And we'll build on that tool quite a lot in the workshop exercises. Just a few more tricks with lists that are worth doing. To add something onto the end of it, you can use this append command. So take the list, .append, whatever you pass into that function will be thrown onto the end. You can get the length of a list by doing len and then input the list. And you can also iterate over the items in a list. So you write for like variable in the list, and this section will just loop over and over each item in the list, first equaling the first, and then second, and third, and fourth item in the list. And so you can use the variable name to kind of access each of those sequentially. And this will come up in the workshop, like trying to work with multiple servo motors at once or stepper motors at once. And we don't want to write the same code 4 times if we can just do a loop. So that's why loops tend to be used. And you can also combine some of these things. This is the, I think, last slide, and I think it's the most complex, but step by step can try to think through what are each of these lines doing, especially this one. And if maybe things are complex, try to think from inside to outside, what's going on. I'll give like a minute or 2 for that, and there we go. A better question is like, what will be printed out? That's the concrete like understanding test. I'll type out my answer slowly in chat. Hopefully it's not visible to people. Does anyone still want time? Or is the idea somewhat there? Yeah. So I have it as like 1, 7, -5, 4. Thought process, let's take it from the top. We define A, and it's going to be equal to this list. We define B, same thing. And we're going to loop over the items in the range of the length of A. Okay, first off, I found this feature today. I thought it was pretty cool. First off, what is the length of A? Well, it's the number of elements A has, so it's 4. It's hard to write, but I think that should be visible. So it's going to be 4i in range 4. So that's actually going to be like 0, and then 1, and then 2, and then 3, because you go from 0 to n-1. And what do you know? Those are actually the indices of the first, second, third, and then fourth elements of each of these lists. So for each iteration of I, we're going to have like A0 plus B0, which is 1. You'll print that out. We're going to have A1 plus B1, print that out. Same thing for 2 and 3. And so that is where I got the answer from. Okay, do I know how to clear this? Sure. Exit that. And yeah, that's all we're actually going to cover in terms of reading and looking at code syntax. Does anyone have any questions on that section before we talk about the workshop code exercise examples? So we covered a lot. I wouldn't pretend that it's easy, but we have actually covered everything that's needed for the rest of the workshops in terms of at least looking at the syntax. Obviously, some of the later workshops use classes and complex. Really, they're just classes, but of course, they're a lot of classes or a lot of code to read. But all the parts you're going to be working with build on lists and variables and member variables sometimes as well. So we've actually covered like a surprising amount of useful stuff. That's the end of the slides. So really the final part of the workshop is, we call this intro to programming. I think there are two ways to learn programming. There's first just reading to like understand syntax, and well, there really are three parts. There's the ideas, which I think we've somewhat covered. There's reading to just see what syntax looks like, and then there's writing to get practice applying that. I think we've done the first two, and we have exercises here which get us to the final. Maybe the first note is if you haven't, you should now be able to finish like these setup steps for the workshops, and like running this command in steps 12 of either system should get you to a place where you're able to run the workshop code and see what's going on, and that will print out Python code as it goes. And then when you press return, it will run that code repeatedly. So you'll be able to, simultaneously like see what code's going to run, press return and run it. And then at some point it asks you to implement something. You can go into the file, you can do that, and then rerun it. And I mean, yeah, that's it. There are three different like things you'll want to implement in the example code. First off is, I can look at it. The first thing to fill in is going to be making all three servos go back and forth in some like amount of time. The second is just assigning the variables using a function which iterates over the list, which we've seen the syntax for. And then the last one is combining those two to make the dancing behavior in a way simpler way using functions instead of other stuff. It's pretty simple exercises, but it goes through a lot of the iteration and function stuff we had before. So really, like, that's all I have. If anyone has any questions about finishing the setup or just the exercises, like, that's really all that's left.